lesson today is 4.4C, and it is area models with partial products. During the lesson today, we're going to think about how can we use area models to multiply large numbers. In this lesson, we will learn what area models are and how to use them to solve multiplication problems. We're going to be talking about multiplying a two-digit number by a one-digit number. We're not going to go to the algorithm right away. We're going to do something with area models, and this will help you if you get stuck on another way to figure out and find the answer. So let's look and see what we have. Okay, basically this is an area model right here. And what they've done is they've taken the algorithm, 13 times 12, and they've broken it down into parts. And they broke 13 down to 10 and 3, and they broke 12 down to 10 and 1. Well, we know that 10 by 10 is 100. So we have a 100th block right here, and there's your 10 by 10 is 100. We know 13, 3 times 10 is 30, so 10, 20, 30. Here's your 10 times 3. And we know that 3 times 3 is 6, or 2 times 3 is 6, and so we have 6 right here. And then we know 10 times 2 is 20, and when we add all these sections up, we come up to 156. So this is one way to find an answer to a multiplication problem. Okay, basically what you're going to do is we took the algorithm 53 times 4, and we broke 53 down. It's the largest number, and we broke it into expanded form, and we wrote it across the top, and we said 50 plus 3. You want to try to break it down where one of your numbers is ending in a multiple of 10. So write that number horizontally on top. Then we write the 4 vertically. Now we need to multiply the 4 times each number on top, 4 times 50. So we know from the other day that 4 times, multiply the single digits if you can, 4 times 5 is 20. But we know we're not really dealing with 20 because we actually multiplied by 50, so we're dealing with 200. That means I'm going to pull over 2 flats, which are worth 100 each. Then we're going to multiply 4 times 3. Well, I know 4 times 3 is 12, so I'm going to bring over 1 rod and 2 units. And when I add that up, I've got 200 plus 12. My answer is 212. Okay, let's do another one. Okay, I've got 70 plus 8. The algorithm was 78 times 5, so we broke 78 down to 70 plus 8, and then we put 5 over to the side. From the other day, I know that if I multiply by the single factors, 3 times 5 is 35. But I know I'm not multiplying by 7, it's 70, so I'm going to bring my 0 over. So I'm going to bring over 3 flats to represent 300. Now I have to bring over 50, so I'm going to bring over 5 rods, 10, 20, 30, 40, 50. Okay, now I'm going to multiply 5 times 8. And I know that 5 times 8 is, and if you said 40, you are correct. So now I'm going to bring over the 44 rods, 10, 20, 30, 40. Okay, and now I'm going to take those two numbers, 350 and 40, and I'm going to add the partial products together. Here's part and here's part. And the answer is 390. Partial means part of, and so that's why these are partial products. Products is an answer to a multiplication problem. So let's go on. Okay, we've got the algorithm 34 times 7. So we broke it down to 30 plus 4, and we put the 7 to the side. Well, I know using simple facts that 3 times 7 is 21. But again, I didn't multiply by 21, or 3, I multiplied by 30, so that's 210. So I'm going to bring over 2 flats, 100, 200, and I'm going to bring over 1 rod to represent 210. Now, 7 times 4 is, you're right, it's 28. So I'm going to put 28 up here. And I'm going to bring 2 rods, 10, 20, and 4 units. 1, 2, 3, 4. And I'm going to add them up. So 210 plus 28 is 238, and if I count my models, 100, 210, 20, 30, 1, 2, 3, 4. Oh, I didn't bring enough units over. 5, whoops, 6, 7, 8. Now we've got it right. Sometimes I have to check myself. In fact, I have to check myself all the time. All right, let's go to the next one. All right, we've got the algorithm is 57 times 9, and we broke it down to 50 plus 7. So again, using the simple facts, I know that 9 times 5 is 45. But I'm adding my 0 because I multiplied by 50 instead of 5. So I'm going to bring over 4 flats to represent 400. And I'm going to bring over 5 rods to represent 50. Okay, now I'm going to multiply 9 times 7, and we know 9 times 7 is 63. So I'm going to bring over 6 rods, 6 groups of 10, and 3 units. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, I know right there I have 10. That means I can exchange those 10 groups of 10. I'll just kind of throw them out of the way as they bounce around. And I can exchange them for 1 flat or another group of 100, and it will make it so much easier for me to count. And then I need 3 units. 1, 2, 3. If I look at my picture and I count my models first, 100, 200, 300, 400, 500, 10, 11, 12, 13. Well, let me see if my numbers added up to that. So I've got 450 plus 63 is 311. There you go. 513. Okay, let's keep going. Okay, now that you know how to use base 10 blocks to represent an area model, let me show you another way that will be faster and easier. Okay, now we're going to do something, and it kind of reminds me of a house, because a house has house plans, right? And you've got the bedroom, and you've got the living room, and you've got the bathroom, and you've got the kitchen. Well, this area model, to me, represents kind of like a floor plan. So, first thing I'm going to do is look at my algorithm, and it is 75 times 6. Well, I want to break 75 down to 70 and 5. Okay? I want to bring 6 down here and put it horizontally, just like we talked about. Okay, so the first thing I'm going to do is multiply 6 times 70. Well, again, using simple factors, 6 times 7 is 42, right? But we're not multiplying by 7, we're multiplying by 70, so it is 420. And then 6 times 5 equals 30. Now, if I take 420 plus 30, and I add them together, the answer to these two partial products is 450, so the answer to this algorithm should be 450. Let's move on. Okay, now, in your journal, I want you to copy this down. I want you to create this model right here. Just like I said, the floor plan, we're going to say this is a living room, that's a bedroom. My algorithm is 82 times 7. So I'm going to break 82 down to 80 plus 2. And I'm going to put my 7 over here to the side. So the first thing I'm going to do is multiply 7, use these factors, 7 times 8. We know 7 times 8 is 56. But we didn't say 56, we said 560 because we multiplied by 80. So 7 times 80 equals 560. Then we multiplied 7 times 2, and we said that equals 14. Now we're going to add those two partial products together, 560 plus 14, and our answer is 574. Okay, let's go on. Let's do the next one. Okay, again, draw this partial product in your journal. All right, we're going to break 47 into what? You're right. 40 plus 7. And we're going to bring the 4 over here to the side. So we're going to multiply these two simple factors. 4 times 4 is 16, but remember we're not multiplying by 4, we're multiplying by 40, so we're going to add that 0 and it becomes 160. We're going to multiply 4 times 7, which is 28, and now we're going to add 160 plus 28, and our answer to the partial products is 188. Let's see if we have another one. I think we have a couple more. Click below to go with helpmath.com to create your own area model practice page. We're going to stop here because we're going to do some practice with our groups, and I'm going to give you some story problems to work on. Guys, thank you so much for paying attention today. I know that this is something that is a little bit different, but we're going to work through it. It really is a simpler way if you're working on 2-digit times 1-digit, or even 2-digit times 2-digit, to help you get the correct answer. Okay, see you later. Bye.